for example, if we have got say this as the signature analyzer, now this M we are getting the input. Suppose the fault free signature is this one, that is for the first pattern it generates 1, second pattern 1, third pattern 0. So, like that it generates the thing. Now, in a initially all these cells are having 0, they are reset, and these if you follow this operation, then after the first cycle this 1 is XORed with 0. So, this 1 comes to the cell R 0 and these contents get shifted. Then in the second cycle again this is 1. So, this 1 will be XORed with again 0. So, 1 comes here and 1 goes there. So, that way at the end of all the test pattern application, so we have got this response as 1011. So, this is the fault free signature or also called the golden signature. Now, if there is a fault, like say there is a fault F1 such that for this particular pattern the response instead of being 1 it is 0. Okay. Then this then if we follow the operation, then at the end we find that the response signature becomes 1110, which is different from 1011. So, if we do a fault simulation before running this session, so if we do a fault simulation, we can check that we can identify that situation, that if this is 0. So, they say due to fault F1, so this output has become 0 and this output has become 1. Okay. So, these two are the changes. The rest of the patterns they did not have any effect on this on this particular fault, but these two patterns their responses got changed. So, ultimate response is 1110. So, through fault simulation we may know that if the response is 1110, that means it is fault F1. Similarly, if the fault F2 has occurred, maybe this response and this response, so all these have changed. So, this pattern, this and this, all these test patterns the responses are different. So, in that case we can say that there is a signature, the signature is 1011. So, in this case you see that this has aliased with the fault free response. So, fault F2 could not be detected by this particular signature analyzer. Okay. So, this is the aliasing that has occurred. So, the fault free response and the faulty response they are becoming same. Another possibility of this signature analysis is the multiple input signature register. The problem with single input signature register is that we have got only one input to the signature register. So, if a circuit has got multiple outputs, then we need some sort of parallel to serial converter to be used before that, so that we can send all those responses serially. And it is very difficult also, because after applying one test pattern, so you have to shift in all those outputs into that chain and all that. Or other option is that out of the say m outputs of the system, you select one output and only use that output for signature analysis. So, in that case also we will miss many cases, many interesting situations that may occur. So, other possibility is to have a multiple input signature register, or MISR. So, here for each of these, so each cell this XOR gate, so we have got another input here. So, in the previous case these individual cells we did not have the XORs. So, now we have got individual cells as XORs. Now, these M0, M1, M2, so they are fed as patterns to this individual flip flop, individual XOR cells. Now, an n input MISR, it can be remodeled as a single input SISR with effective input sequence Mx and effective error polynomial Ex. So, this is a theoretical result, we do not have time to go into that, but the effective input sequence Mx is M0x plus x M1x plus x n minus 2 M n minus 2 x, like that, and the error polynomial is this one. So, if this error, if there is some error, then this error polynomial will tell us what will be the signature at the output. So, again it follows that polynomial division philosophy, and the remainder is the error polynomial. Coming to the example, so this is that 4 stage MISR we have. So, M0, M1, M2 and M3, so they are fed here. So, M0 is first this M0 is coming here, then after one cycle. So, since this is a shifted version, so we can also consider as if this M0, M1, M2, M3, so they are getting shifted, because this is 0. So, when this first line of M1 is applied, so that will not have any effect. So, this will the M1 will remain unaltered. So, that way it will go. So, this equivalent this 4 stage MISR, when we apply M0, M1, M2, M3. So, M0, M1, M2, M3 are like this, they are applied in a time shifted fashion, then this is the resultant polynomial M. So, the previously that Mx that we are talking about, so this becomes the equivalent M sequence, and aliasing probability is given by this expression. Now, that is about the this test pattern generator and the response analyzer. Now, there are several logic based architectures. There can be 4 types of logic based architectures. No special structure to the, when in one case we do not have any special structure to the circuit. We use there are scan chains in the circuit. So, we try to use those scan chains. We can configure the scan chains for test pattern generation and output response analysis, because this test pattern generator, so it is nothing but a set of flip flops and XOR gates. So, if we can modify the scan chain itself, so that in some test pattern generation mode, so it will be acting, the XORs will get activated. So, that way it can act as the test pattern generator. And the response analysis, here also there is some summation. So, that is also acting as some XOR gates are there in the circuit, that is getting inserted. So, if we can modify the circuit, so that we can if we can modify the scan chain, so that when required they can act as pattern generator or response analyzer. So, that can be done. So, if it is done, then also this is going to be useful, or we can use concurrent checking circuitry of the design. So, that can also be done. So, the first one is the centralized and separate board level BIST or CSBL. Here 2 LFSRs and 2 multiplexers are added to the circuit. The first LFSR acts as pseudo random pattern generator, second LFSR acts as the single input signature register. The first multiplexer selects the input and another routes the primary output to the SISR. So, what is happening is that there is a pseudo random pattern generator and there is one SISR. So, these 2 are added, and then these primary inputs are there, but from the pseudo random. So, in the test mode, this multiplexer will select the primary input, the pseudo random patterns that are generated to be applied to the circuit, and then this k equal to log m. So, this basically if there are m lines going out of there are m primary outputs going that are there, then out of that, so it will select which of them will go to the SISR. So, basically this outputs will be fed serially to the SISR. So, after applying one pattern, after this pseudo random pattern generator has generated one pattern, and through this multiplexer it has been applied. So, there are m outputs, so those m outputs will be selected serially and put into this SISR. So, this structure can be used as a for board level So, we can if there are circuits which are fed by the same PRPG, so that also can be done. That also can be done by means of some other selection lines, like if the test signal given to the first module here. So, it can be given to some other module as well. So, we can select between the module to be tested or circuit to be tested. So, this is one type of board level BIST. Another one is built in evaluation and self test or BEST type of structure. So, here we use a pseudo random pattern generator and a multiple input signature register. Then the pseudo random patterns are applied in parallel from the pattern generator to the chip primary input. So, here it is very I should say some sort of very dedicated pattern generator and signature register that we have, and then this is very comfortable, because now if the circuit has got say n inputs, then this PRPG is also n bit wide. So, these n bits are generated and fed parallelly to the circuit. And similarly, this if the circuit has got n outputs, then the MISR is an n bit output. So, that will be fed to this thing. So, these patterns, the pseudo random patterns are applied in parallel from the PRPG to the chip primary inputs, and MISR is used to compact the chip output responses. So, this output responses will be compacted by MISR. So, there may be some bypass mechanism when the circuit we do not want to test. So, in that case this primary input will be applied directly to the circuit, or this outputs primary outputs will be available from this circuit, but in test mode. So, it will work like that. Another approach that we can have is LSSD, that is level sensitive scan design, that we have seen previously for on chip test, on chip self test, called low cost. So, this what it does, in addition to the internal scan chain, and external scan chain comprising all primary inputs and primary outputs is required. So, this this circuit, it has got one internal scan chain where SI is the scan input, SO is the scan output. Apart from that, we have got separate scan these scan lines are there. So, this what happens is that from the pseudo random pattern generator, this pattern is generated, and then that goes into this shift register latch, and this shift register latch. So, it can either pass this primary input to the circuit, or it can serially shift the pattern that are coming through this R1 line into these latches, and then these values will be loaded into this scan chain as well. So, the primary inputs and the scan chain inputs, so they are fed from the PRPG, the pseudo random pattern generator, and the response part similarly, the scan chain output and this primary output. So, they are all put into this serial latch. Then this in the serial latch they are loaded, and then they are going to SISR one after the other. So, this way, this apart from this internal scan chain that we have, externally two scan chains are connected, one for the scanning part, this pseudo random pattern scanning part, and one for the pseudo this response this scan chain output response part, that is routed through this and coming to the SISR. Then there is another very popular structure which is known as self testing using MISR and parallel shift register. So, SRSG. So, they are called, that is called stumps. So, this contains a pseudo random pattern generator and one MISR. The scan chains are loaded in parallel from the pseudo random pattern generator. The system clocks are then pulsed, and the test responses are scanned out to the MISR for compaction. So, let us see how this structure looks like. So, this is the stumps structure. So, this circuit that we have, so it has got a number of scan chains. Okay. So, these are the internal scan chains that I have. Now, from the pseudo random pattern generator, so they are actually feeding these scan chains. Okay. And these responses of the are collected from this scan chain to the MISR. Now, so this is a typical stump architecture. Now, it may so happen that this process requires so this number of scan chains is much larger than the PRPG, the pseudo random pattern generator. So, so we cannot make it very large, because that will increase the circuit area, power consumption and all that. So, what can be done is that we make this PRPG small, but then it goes through a linear phase shifter. So, this produces more number of shifted versions of these outputs. Okay. Now, this and then they are actually used to feed the scan chain. So, if we have got large number of scan chains in the circuit, then we can use this philosophy to feed the feed those scan chains without doing anything, without having a large PRPG. Similarly, at the response side as well, we have got a linear phase compactor. So, what this linear phase compactor does is that it actually combines some of the outputs, and then it is fed to the MISR for signature analysis. So, from for connection, so this MISR is of smaller, maybe of smaller length, and this linear phase compactor, so it combines a number of outputs into one of them. So, that way, if this side may be a more number of inputs may be coming to this phase shifter, phase compactor, and this output will be much less than that, that will be put into the MISR. Then there is another structure which is known as built-in logic block observer, or BILBO. So, BILBO is a circuit that combines all these operations into one. This architecture applies to circuits that can be partitioned into independent modules or logic blocks. Each module is assumed to have its own input and output registers or storage elements, or such registers are added to the circuit where necessary. The registers are redesigned so that for test purposes they act as PRPGs or MISR. So, this is very important. So, these extra registers that we are adding, they themselves will act as pattern generator or signature register. So, this is a typical Bilbo structure. You see that it has got several modes. So, there are two control signals B1 and B2, and this functional data, when B1 equal to 1 and B2 equal to 1, what is happening is that this Y0 value is getting loaded into this flip flop. Similarly, Y1 value is getting loaded into this flip flop, Y2 is getting loaded into this flip flop. So, that way for both of them being equal to 1, so this circuit operates in the normal mode, Y0, Y1, Y2 loaded into these latches. Next, if we have this both of them as 0, B0, B1 both of them are 0. So, if both of them are 0, then this will be selecting this line. So, this line will be selecting this scan out or X2 line. So, that will be coming here, and this will come here. This is both are 0. So, this will be this, if this whatever is coming on this line. So, it will be appearing at this point, and at the output of this NOR gate, that line, the inverted version of that will come. So, inverted version of this 0 input is coming here, and then this is, so this part, since this is 0, so this input is 0. So, whatever you are getting here will be coming to this point. So, that way the value that we are going to store, that we are going to shift in, so that will be the scan in. So, that will be coming into this picture. Now, after that, in the next cycle, so if we have got say 1 0, so that is a mixed mode, mixed test generation and signature analysis. So, in this case, this signature analysis will this mixed test generation and signature analysis. So, this will be the circuit will be operating in the test generation and signature analysis mode. So, when this is 1 and this is 0, so this B1 equal to 1. So, B1 equal to 1 will select this whatever scanning input is coming. So, it will be loaded into this D flip flop, and then this B2 value B1 value being equal to 1. So, this value will be XORed. So, whatever is coming here in Y0, so that will be XORed with this value. So, as a result, this will be acting as signature register now, and also it works as test generator like this. At this point, this X0, X1 and this X2. So, they will act as the test pattern that is getting generated, and they will be, since this shifting is there. So, it will also act as the shift register. So, I would suggest that you go through these different modes B0, B1, B2 settings, and you can find that okay, for all these cases different modes. So, it is doing these operations in as required. So, for 1 it is normal mode, for 0 it is scan mode, 1 is test generation and signature analysis. So, this is basically the BIST mode we can say, and 1 is the reset mode, where it is the content is getting reset. There is another structure which is known as C Bilbo or concurrent Bilbo. So, so here actually these individual stages are there, but they can operate simultaneously. So, this is the here we have got 3 modes, like whenever B2 is 0, so that is the normal mode of operation. So, B2 being 0, so these cells are same as what we have seen previously. So, they will act as a normal mode of operation. When this is 1 1, so it will act as scan mode, and when it is 0 1, it will act as test generation and signature analysis mode. So, this is otherwise it is similar to that Bilbo structure, but it is concurrent Bilbo because we have got 3 different Bilbo modules, and they can act for 3 different modules in the circuit. So, all of them are tested parallelly. Then there is another structure which is circular self test path. So, here this is one shift register and MISR is there. So, this circuit under test. So, this pattern will be applied, and this is going to be circulated, in the sense that when the circulate input is 1, this MISR's response is again put into this shift register. So, that the same test pattern, whatever response was generated, so that is actually again fed as test pattern for the shift register. So, if it is circulate is 0, so we can shift in the pattern, new pattern can be shifted in, and when this circulate bit is 1, so it is basically the same, the response that is generated by the circuit and MISR. So, that is fed as the pattern for the shift register. So, this way this self testing will work. Then there are concurrent self verification approach. So, here this pseudo random pattern generator that we have. So, we have got two circuit, the functional circuit and the duplicate circuit, and then we have some checking circuitry. So, basically it checks whether these two responses are correct or not. So, if these two responses are same, then it will say it will check that whether if either of the circuit is faulty, then this response will not be same. Okay. So, that way it is some sort of I should say confidence that a circuit gets on its own operation, whether it is working correctly or not, because if the circuit is working correctly, then both the responses will be correct. If the checking circuitry says false, then either of them is faulty. Okay. So, there you can say that the system is not working properly. So, we can say that a faulty situation has been detected. So, the advantage is that we do not have any MISR sort of thing. So, that way it is going to be helpful. So, to summarize, so we have got different types of structures, we discussed some of them. So, out of all these structures that we have seen, the stumps is one industry standard. So, that is accepted widely for this BIST architecture, but the problem are due to this low fault coverage. So, there is some proposal that C Bilbo based architecture that could perform always that would perform, that whether this will give 100% fault coverage or not. So, that is a question in the C Bilbo, it is not yet established, and whether this pseudo exhaustive testing would become the preferred BIST technique. So, instead of going for the pseudo random testing, should we go for pseudo exhaustive testing.